Alright, so today's notes we are talking about balancing equations yet again, kind of going off of our counting atoms that we've been doing. We're sort of going to tie counting atoms into the bigger picture in chemistry and like why we need to be able to do it. And if you're still struggling with counting atoms, don't worry, we're going to do plenty more practice with it. I just kind of want to frame it in a way that it makes sense why we're doing it and like what its relevance is. So the reason we count atoms is because we have to determine if chemical reactions are balanced. And what's a chemical reaction? Well, basically it's when some chemicals get in contact with each other, the bonds between those chemicals get broken, and then all the atoms rearrange, they form some new bonds, and you get some new stuff. So that's like a super simple breakdown of what a chemical reaction might be. And let's just go forward and kind of talk about that in more detail. So the big idea is that in a chemical reaction, something new will get produced. Something new, right? Without something new being produced, it's not a chemical reaction. Think chemical versus physical change, right? All right, so in a chemical reaction, we have these things called the reactants. You saw that on the previous slide. And I said that's kind of what we started with. So the atoms and molecules that like first come into contact with each other and they first interact with each other, we call them the reactants. And the easiest way to think about it is the reactants are what does the reacting. They are the first things you see. They are the things that react with each other to have a chemical reaction. I know I'm saying the word react a lot, I'm sorry. Then we've got the products. So, like I said, a chemical reaction is when a bunch of chemicals come together and like basically interact. A bunch of bonds get broken, the atoms all rearrange, and you get some new stuff. That new stuff is called the products. The products are what get produced at the end of a chemical reaction. So again, reactants are what do the reacting, products are what get produced. So this is kind of like the anatomy of a chemical reaction. You see we've got reactants over here. We've got products over here. And there's some coefficients, we talked about that. But the idea is that like these two things, this H2 and this O2, they are going to interact and they're going to form something new. They're going to form H2O. This arrow, it basically means yields or reacts to form. So it's sort of like an equal sign, right? The general anatomy or the general way a chemical equation is always going to look is reactants, and then an arrow, and then products. So basically you're saying the reactants are going to react to form the products. And what's super important to know about this is that whatever is present in the reactants cannot get created or destroyed. It might like change how it looks, it might change form, but it can't be actually destroyed. No new atoms are going to get created or destroyed. Basically, we're going to have all of the same atoms just arranged in a different way. And we call this the law of conservation of mass. All right? So you might have heard of the law of conservation of energy, where energy can't be created or destroyed. This is really similar. It's saying that atoms don't get created or destroyed. So in order for an equation to be balanced, there has to be the same number of reactants and products. And why does it matter that we've been counting? Well, because we have to be able to count how many of each atom are present in the reactants and in the products. So let's go back really quick to this. Like we'd have to count how many H's are present right here, how many O's are present right here in the reactants, and then how many H's are present in the products, how many O's are present in the products. There's always got to be the same amount of atoms on each side. even though on this side it's different, it's split apart, it's H2 plus O2, and on this side it's H2O, notice that we didn't create or destroy any new atoms. We're not like randomly throwing a carbon in there. We've got the same stuff we started with. So that's our big idea for today, that we don't create or destroy atoms. And that is why we are counting atoms, so we're going to be able to better tell if an equation is balanced.